Hi, good morning. Good morning, everyone. Good morning, dosto. So, today we are, first of all, welcome to Just Get Civil. And we are going to start the discussion for environmental engineering. Today- And today is the first class. First, we need to know for this crash course that for environmental engineering, what will be the, well, for environmental engineering, what will be the process, how we'll deal with this segment. So first of all, let me introduce myself. I am Soumyajit Sen. I've done my masters from IIT Bombay, and last 6+ years, almost 7 years, I am in this field. And my specialization is area of specialization is environmental engineering and hydrology generally. Well, let's move to the part before starting the chapters and thing. Those who have not done with this segment, that you can go for first you can search in your Play Store or iMobile app, that Unacademy learning app. Then you can click the install button, and then you can go for the gate and EAC, because whatever views are there for gate and EACs. Then you can go for Unacademy Plus, and you can go for this subscription, gate subscription. This is my code. If you want, you can use this my code, and you will get that the 10% of direct discount over there. And finally, you will be entering to that segment where you can get all the topmost educator classes in the Unacademy segment. ये और एक चीज है जैसे Unacademy Combat, where that is a thing which is actually going to happen, and this challenging questions is done. ये एक challenge है, ये एक part है जहाँ पे आप लोग आप एक question solve करोगे, और उस question solve के हिसाब से कुछ prize monies भी हैं, और eventually these questions are set by all those topmost educators. Ranking, real rankings are real time rankings, and obviously in this platform you need to compete with the best. Then you can find out that what is your position there, how you have done in your preparation segment. And after the completion of these things, the detailed video solution by top educators will be provided, and those video solutions, from that solution you can find out that whatever correct things or whatever mistakes you have done during the solution process. Awards will be there. First prize will be Apple MacBook Air. Second prize will be Apple iPad Mini. Third prize is Apple AirPods. And top 100 rankers will get rupees 1000 Amazon vouchers. So it's quite a lucrative offer is provided in Unacademy Combat, and it is free enrollment is there. You can register now. And another part for Evolve for Gate 2020 Civil Batch A, from 28th December 11:15 a.m. There is the thing, that is this segment also you can go through. Well, let's come to the subject part. So eventually when we are talking about this environmental engineering, then so come to the subject part once again. So when you are actually concerned about the subject part, now environmental engineering अगर आप देखोगे, पहला तो है कि भैया ये environmental engineering से एक गेट पेपर में आपको 10 से 12 मार्क्स मिलने वाले हैं. Now you are going to get 10 to 12 marks, and ये 10 to 12 मार्क्स मिलने के लिए आपको जितना ज्यादा एफर्ट आप दूसरे सब्जेक्ट में लगाना पड़ता है, that is not required. This particular subject you can get this 10 to 12 marks with ease. So actually rank boosting subject है ये सब्जेक्ट के लिए आपको मतलब ऐसा नहीं है कि बहुत ज्यादा एफर्ट देना पड़ता है, ये भी नहीं है कि बहुत आसान है. ऑब्वियसली सर्टेन थिंग्स यू नीड टू रिमेंबर, certain formulas you need to remember, certain derivations you need to remember, but questions are actually prototypes. Obviously certain things are getting changed year by year, but generally if you see, you will see prototype questions over there. In some cases you will get that okay, these are the chapters or these are the segments from where you will get more, you can give more emphasis and you will get more effects over there. So these things are there. Now the point is, अगर हम इस कोर्स को मतलब देखते हैं कि किस तरीके से ये तोड़ा जा सकता है एनवायरमेंटल इंजीनियरिंग को, तो आपको 5 सेगमेंट मिलेंगे. वाटर सप्लाई इंजीनियरिंग, वेस्ट वाटर इंजीनियरिंग, सॉलिड वेस्ट मैनेजमेंट, एयर पोल्यूशन इंजीनियरिंग एंड नॉइज पोल्यूशन इंजीनियरिंग. You will get total of 5 segments: water supply engineering, wastewater engineering, solid waste management, air pollution engineering and noise pollution engineering. These segments you will get. Now water supply engineering, wastewater engineering, ये जो part है ये actually water part है, और ये solid waste management, air pollution engineering, noise pollution engineering, this is the non watery part. तो ये दो वाटरी पार्ट है, नॉन वाटरी पार्ट से आपको मिलेगा कि ये पूरा एनवायरमेंटल इंजीनियरिंग का सेगमेंट हो जाएगा. अगर आप देखोगे ये 10 से 12 मार्क्स का एक डिस्टिमेशन आप अगर देखोगे तो नॉर्मली हाईएस्ट मार्क्स यू आर गोइंग टू गेट फ्रॉम दिस वाटर सप्लाई इंजीनियरिंग सेगमेंट, एंड दैट पर्टिकुलर सेगमेंट विल टेक मैक्सिमम अमाउंट ऑफ टाइम टू गेट फिनिश्ड. फॉर वेस्ट वाटर इंजीनियरिंग you will get around 4 to 5 marks questions, and with solid waste management, air pollution engineering and noise pollution engineering you will get around 2 marks questions. Though nowadays from noise pollution engineering segment, this particular segment is not there in this gate 2021, but when you are preparing for gate, sometimes you need to get prepared for PSUs also. For PSUs that particular segment is there, so that's why I am inculcating that particular segment also in the syllabus or in the study material, or what you can say the study flow. So from that non watery segment you can expect around 2 marks. तो बात ऐसा है कि भैया अगर आपको ये 10 से 12 मार्क्स के लिए क्या है कि एक कोर्स के साथ आप एक महीने का एम्फसाइज दोगे, अगर हर रोज थोड़ा सा ब्रशअप चलेगा तो इवेंचुअली व्हाट यू विल गेट अ डायरेक्ट प्रोसेस, वो 10 से 12 मार्क्स आपको मिल जाएगा. एंड एग्जाम हॉल से निकलने के बाद आप इतना तो समझ में आएगा कि आपको कि ये 10 से 12 मार्क्स के लिए जो एफर्ट आपने दिए हो, और बाकी वही 10 से 12 मार्क्स के लिए अगर दूसरे सब्जेक्ट में आप जो इतना एफर्ट दोगे, इसी एफर्ट से कई गुना ज्यादा होता है वो. कभी कभार इट्स ट्वाइस और थ्राइस देन दिस एनवायरमेंटल इंजीनियरिंग. देन आल्सो दोस 10 to 12 marks is not secured, whereas this 10 to 12 marks is secured. You go through this course, आपको ये कोर्स जैसे मैं मतलब पढ़ाऊंगा या डिस्कस करेंगे, एक्चुअली दैट इज अ इंट्रोडक्शन सेगमेंट, जैसे हम लोग डिस्कस करेंगे इस कोर्स को, यू गो थ्रू दैट, यू विल गेट दैट पर्टिकुलर थिंग दैट की हो क्या रहा है, एंड अल्टीमेटली आई एम गारंटिंग यू दैट यू विल गेट फ्रॉम 10 to 12 मार्क्स के सेगमेंट से 8 से 9 मार्क्स का मैं गारंटी दे सकता हूं. बाकी 1-2 मार्क्स का क्या होता है कि कभी कभार वो सीक्वेंशियल सेगमेंट हो जाता है कि वो थोड़ा सा इनोवेटिव कुछ चाहिए होता है, बट दैट थिंग यू नीड टू इनोवेट योरसेल्फ इन द एग्जाम हॉल. Now so we can go for these objects of environmental engineering. Now what will be the objects of environmental engineering? Now when we are concerned about the objects of environmental engineering, then first we need to know that two types of things actually going to happen. या तो आप एनवायरनमेंट में कुछ खराब किए हो, या तो नेचुरली एनवायरनमेंट में कुछ चीजें प्रेजेंट हैं जो जो आपके लिए सुटेबल नहीं है. नाउ तो नेचुरली सुटेबल नहीं है. तो द थिंग्स विल, like in case of environmental engineering, uh, first object is protect the human being from environmental factors. अगर आप देखोगे कि सब्जेक्ट ओवरव्यू में, तो यहाँ पे वाटर सप्लाई इंजीनियरिंग है, वेस्ट वाटर इंजीनियरिंग है. वाटर सप्लाई इंजीनियरिंग में क्या होते हैं, क्या करते हैं हम? We are going to choose a source of water and we will convert the source of water into drinking water sources. We will convert the source of water into drinking water sources. So that is there in water supply engineering. And in wastewater engineering, what we will do, there the wastewater, actually we will generate the wastewater, we will convert the domestic water into wastewater, and in wastewater engineering we will uh, remove the pollutant from the wastewater before dispose it off to the natural water sources. सो इन वाटर सप्लाई इंजीनियरिंग हम क्या कर रहे हैं? इन वाटर सप्लाई इंजीनियरिंग में हम जो नेचुरली जो पॉल्यूटेंट और इम्प्यूरिटीज प्रेजेंट है पानी में, जो हमारे सेहत के लिए हानिकारक है, उसको हम हटाने का कोशिश कर रहे हैं. सो इवेंचुअली आवर फर्स्ट ऑब्जेक्ट दैट प्रोटेक्ट द ह्यूमन बीइंग फ्रॉम एनवायरमेंटल फैक्टर्स इज बीइंग डेल्ट in the water supply engineering segment. Whereas in the second segment, that wastewater engineering, in that particular segment, we are protecting the environment from the human factors. We are protecting the environment from the human factors. क्योंकि जो वेस्ट वाटर है, वो वेस्ट वाटर is generated from your domestic sources, from industrial sources, or from other institutional or commercial sources. Those all the sources are human induced sources. So in that wastewater segment, we are actually protecting the environment from the human induced factors. In solid waste management also, actually that particular thing where solid waste is generated by human induced manner, उधर भी हम लोग एनवायरमेंट को प्रोटेक्ट करेंगे, एनवायरमेंट को सही सलामत रखने का कोशिश करेंगे, बिकॉज एट द एंड ऑफ द डे अल्टीमेटली दैट विल हैम्पर आवर लाइफ. So these are the two major objects of environmental engineering. First of all is the protect the human being from environmental factors and the protect the environment from human induced factors. Now coming to the water supply scheme. वाटर सप्लाई स्कीम क्या है, कैसे कलेक्ट करेंगे, क्या करना है? पहला तो है कि इस स्कीम में पहला आपको जो देखना है, दैट इज water source. You need to find out, you need to choose a source of water. आपको चुनना है कि कहां से पानी सप्लाई करेंगे. Obviously this choosing of water is not like abrupt choosing of water. First you need to find out कि कितना पानी चाहिए. अगर बहुत ज्यादा पानी चाहिए होता है और आप एक छोटा मोटा सोर्स चुने होंगे, so that will not work. So you need to find out a proper source of water, and that proper source of water, after that you need to collect the water from that source. So there is certain process involved in this collection process. After collecting the water, you need to convey the water from the source to the treatment plant. Now we will see that before conveyance and after conveyance and before the treatment of water, we will go for the quality assessment of that water. Why? Because we need to know the problems associated with the water. So after conveyance there will be quality assessment, and then according to the quality of water, according to the deviation of the value of the impurities from the ideal value, we will impose of the treatment unit. We will impose of the treatment unit. After treating the water, we are going to distribute the water to the household persons or the community. And in another cycle, that community will use that particular water for the domestic uses, for the industrial uses, for the commercial uses, and that community will generate certain waste. So that wastewater you need to collect, And after collecting the wastewater, you need to treat the wastewater for proper disposal. Proper disposal means that before disposing that wastewater, you need to treat and you need to ensure that the disposal of that wastewater is not hampering the natural water body quality or the properties that much. Understood? So if we see the thing that this particular segment from water source from this water source is collection, conveyance, this treatment, distribution, community, all these things are actually the process of water supply or domestic water supply engineering. Domestic water supply engineering, all these things you are doing here. But once again, if you see this particular segment of the collection of waste and the treatment and disposal, this particular segment is actually the wastewater engineering segment. So it's a cyclical process, water supply engineering, interrelated process, water supply engineering and wastewater engineering, interrelated process. Okay. Now, first thing is what you need to know that what will be the basic parameter to for this for the design of water supply scheme. What will be the basic parameter? क्या करना है आपको, क्या choose करना है? Now, in this scheme, first you are actually finding out the source, then you are collecting that water from the source, you are conveying the water from one place to another, you are treating that water, then you are distributing the thing. So what is the main thing? What is the first most uttermost parameter for this water supply scheme you need to be concerned about? The first most parameter what we need to be concerned about is the Q. How much water you need to supply. Yeah, you can say it's volumetric load, or it is, if it is volume per time, then volumetric flow. Because until unless you are finding out कि कितना पानी supply करना है, you will not get that what will be the source of water or what source you need to choose. So, to design the water supply scheme and water disposal scheme, we require the discharge Q, hydraulic load. To design the water supply scheme, we require the discharge or hydraulic load Q. Just a minute. So, to design the water supply scheme and water disposal scheme, we require the discharge or hydraulic load Q. Now this discharge or hydraulic load is actually the function of two parameters. One is population, another one is per capita demand. So how it is getting defined? Suppose in a classroom 40 students are present. Suppose आपके classroom में 40 students present हैं और एक बंदा आया आपके classroom में और आपको पूछा कि और या तो मेरे को पूछा कि सर कितना पानी आपको इस क्लासरूम के लिए पीने के लिए सप्लाई करना है. हाउ मच वाटर आई नीड टू सप्लाई for this classroom for drinking purpose. In this case, quite obviously, the person who is asking for this volume, he or she is concerned about the volume of water supply. Baki kuch nahi. That is the thing, that the amount they need to supply. Then what I will do? I will count the population and I will say, I will take that, okay, per head 1 liter water is assigned for drinking purpose for this classroom. So what will happen then? Then I will answer that person that, okay, you need to supply around 41 liters of water for this classroom for drinking purpose. How I am getting that 41 value? I'm just multiplying the population with the per capita demand. Per capita demand means, capita means person demand. And if population gets increased, your Q value will also get increased. How? Suppose suddenly 10 more students have entered to the classroom. Now your population is 51. Then I will call that person, okay, you don't have to supply that 41 per liter because it will not work. आपको 51 लीटर या 51 लीटर सप्लाई करना है. So आपको अगर 51 लीटर सप्लाई करना है मतलब हमने वॉल्यूम को बढ़ा दिया, Q वैल्यू बढ़ गया. कैसे बढ़ा? How I am getting that 51 value? Multiplying 51 population into per capita demand into 1 liter per capita for this water purpose. So eventually population get increased, your Q value increased. But per capita water demand, whatever I have taken previously population के time पे कि 1 liter per capita per day, वही हम फिर से ले रहे हैं 51 के time पे भी. तो per capita water demand is constant for a particular catchment area. यहाँ पे catchment area मतलब concerned area which and for particular purpose for a particular purpose and for a fixed time frame. For a particular purpose क्यों? मैं यहाँ पे ड्रिंकिंग पर्पस का बात कर रहा हूँ. अगर वो होता क्वेश्चन कि नहाने धोने के लिए, बर्तन धोने के लिए, तो 1 लीटर विल नॉट वर्क. एंड फिक्स टाइम फ्रेम ऑब्वियसली उस क्लासरूम का बात कर रहा हूँ. अगर वहां पे बोला जाता है कि 10 दिन के लिए एक साथ पानी, तो 10 दिन के लिए तो एक आदमी 1 लीटर पानी तो नहीं पिएगा. So the time frame and the purpose and the catchment, all those things has to be fixed. Then per capita water demand is constant for that. Okay. Now we are going for the definition of per capita water demand. We are going for the definition for per capita water demand. Now the average amount of water demanded by an individual living in the community to meet all his or her day-to-day water needs. Average amount of water demanded. Average amount of water demanded by an individual living in the community to meet all day-to-day water needs. And this per capita water demand is defined on the basis of annual average data. That means it is that by their definition or the by formulation part, it is the annual average water consumption of a community by population into 365. Is the annual average water population of a community by population into 365. That is the per capita water demand, and generally per capita water demand is expressed in LPCD, liters per capita per day. Generally, the per capita water demand is expressed in LPCD, liters per capita per day. That particular unit you need to be very much concerned about, because that you will use later on in many cases. Now, now you're coming to, if we see the water supply engineering chapters. What are the chapters we will see in this water supply engineering? First chapter will be water demand and population forecasting. That's what we are going through. Water demand and population forecasting. The second chapter is source of water in brief. So, okay, let me tell you the chapters. Third one is quality of water. Fourth one is treatment of water, and this fourth one segment is consist of certain sub chapters or certain components. Fifth one is the distribution system. In the first chapter, we will see the first chapter is consisting of two segments. One is water demand and another one is population forecasting. Second, so in the first segment, water demand segment, we will see, we will go for this, how much water demanded by a community for different purposes. Then we will go for the second segment, that is the population forecasting segment. In the population forecasting segment, we will see how to deal with the population numbers. In the second chapter, we will choose a suitable source of water, where we will see the ideal sources of water and certain various or we can say cumulatively certain formulas over there. Third chapter, the quality of water chapter, is the most important chapter of this segment, where question is guaranteed. Where question is guaranteed from this chapter. Quality of water. Question is guaranteed. In the fourth chapter, in the treatment of water chapter, that particular fourth chapter, there we will see regarding the treatment of water of by plain sedimentation, coagulation and flocculation, filtration, disinfection. These are the major four components or treatment process. And in miscellaneous treatment, we will see in brief the different groundwater treatment process. In the fifth chapter, there will be distribution system, and that particular chapter where we are going to distribute the treated water to the community. Okay. Now we are going. So as we have started with the water demand and population segment, population forecasting segment. Now we are going for these different types of water demand. First, we are entering to the water demand part, where water demand segment will give you the idea that how much water will be demanded by different segments or for different purpose of a community. So we have entered the first chapter, and there the first segment of the first chapter. So first we have the different types of water demand. What are the different types of water demand? The different types of water demands are domestic water demand, industrial water demand, institutional or commercial water demand, demand for public uses, compensating losses demand, and fire demand. Domestic water demand, industrial water demand, institutional or commercial water demand, demand for public uses, compensating losses demand, and fire demand. Where the domestic water demand is the water is demanded for domestic uses. The water is demanded for domestic uses. And domestic uses means for different domestic uses like cooking, bathing, cleaning of homes, cleaning of utensils, etc. For industrial water demand, for the demand is where the demand is actually done for any kind of industrial uses. For institutional and commercial water demand, that will be the water is demanded for institute or commercial places. Demand for public uses comprises of the water demanded for different common uses like watering of parks or cleaning of roads, etc. The fifth segment, compensating losses demand, that particular segment it will deal with the water which is demanded. The compensating losses demand means here the amount of water which will be demanded for to compensate certain losses, like when the water is actually transported from one place to another, there will be head loss. Sometimes water may be there will be certain leakage loss, so those losses are compensated by this demand. And for this fire demand part, fire demand is actually the demand of water which is there to extinguish and fire accident. To extinguish and fire accident, huge amount of water required. So that amount of water also needs to be accumulated somewhere else or stored in somewhere else. Now, now we are going for this domestic water demand. Now, when we are going for this domestic water demand, so each and every water demand we will discuss in details. In briefly, we will details. So for domestic water demand, generally the water which is demanded for domestic uses will falls under this domestic water demand. Here, 50 to 60% of the total demand is coming under domestic water demand generally. And as per IS 1172 is to 1993, this is the code. Okay, like you may have seen lot many codes in your different courses. So this is the code used for environmental engineering. It's not about the one single code is there. Other code is also there. IS 1172 2004 is there. IS 2008 is there. But generally we will follow for this Indian standard 1172 1993. 135 to 200 LPCD water needed to be supplied for domestic purposes. 135 to 200 LPCD water. Now, this 135 and 200, this value is not abrupt values. Generally, two groups are there. In case of Indian standard, the whole population is divided into two groups. LIG is this low income group, which is also called as without complete flushing system, and HIG is high income group, which is called as with complete flushing system. Please keep these things in your mind. LIG is also considered as without complete flushing system. HIG is also considered as the with complete flushing system. Here, different purpose is mentioned: drinking, cooking, washing of clothes, bathing, cleaning of utensils, cleaning home, gardening, flushing of toilets. Here, for drinking process, LIG people, they are getting as 5 LPCD water. Here the values which are actually 5 LPCD unit values water is there. For HIG people, once again 5 LPCD water is assigned. For cooking process, there 5 LPCD water, and for HIG also 5 LPCD water is assigned. For washing of clothes, as the LIG people will use that buckets and mugs, 20 LPCD water is assigned. For HIG pupil, 25 LPCD. Modern uh, things, electronics, things like washing machines will be used. More amount of water will be used. For bathing, 55-75. Cleaning utensils, 10-15. Cleaning home, 10-15. For gardening, अब LI low income group people उतना शौक पालते कहाँ हैं? For gardening, no water is assigned to them. 15 LPCD water is assigned to the HIG people. For the flushing of toilets, 30 LPCD water is used for this LIG people, and 45 LPCD water is assigned for HIG people. If you add this particular, if you add this particular column, you will get the value 135. Similarly, if you add this particular column, you will get the value as 200. So from here itself, this 135 and 200 LPCD things are coming. So these are not that abrupt values what you it is provided. Okay, it is not that abrupt values 135 200. Now we're going for this industrial water demand. Industrial water demand generally. So here two points we need to remember. Generally 20 to 25% of the total demand, and minimum 50 LPCD of water, 50 LPCD of water has to be assigned. It is 20 to 25% is on the, it can increase, it can be lesser also, but generally it will happen. In the next one is demand for public uses, where we are going for the demand which is like minimum 10 LPCD water. I have already discussed that public uses demand means what we are concerned about. Public uses demand means that particular demand we are concerned about, where water is used for general common public uses, and generally it is the 5% of the total demand. 5% of the total demand, and 10 LPCD water is the minimum to get used. Compensating losses demand, it is minimum 55 LPCD of water. 55 LPCD of water is there, and 10 to 15% of the total demand will be the thing. So minimum 55 LPCD for Western countries, this value will get reduced because certain pipelines are generally cleaned, and leakage is generally they are checked whether leakage is occurred or not regularly. So for our case, these are the values. Next, we are going for the institutional or commercial water demand. Institutional or the commercial water demand. Institutional or commercial water demand means that is the water demand for that is the water demand for institute or commercial users, like different commercial places, office, schools, hostels, restaurant, hospitals, everywhere. Now, here minimum 20 LPCD water is assigned, and generally it is 15 to 20% of the total demand. After that, what I have listed, I have listed certain things that the water demand listed for different places. The water demand listed for different places like offices, schools, residential school, hostel, restaurant, bus stop, railway station, airports, hospital, cinema hall, etc. Generally, For the officer, actually these particular values I have listed here for the MCQ type questions. I will not say that it is required for GATE itself, because for GATE this type of questions they don't ask generally, but for IS prelims and if you are going for any PSU examinations, this is important to know and important to remember. So I have lot many things are there, but I will only listed here the important commercial places. So there, offices, day school, where offices and day school both the places, 45 to 90 LPCD water is assigned. For residential school, 135 to 200 LPCD water is assigned. So hospitals is there, for cinema hall. So these things are there. Hospitals will be of two type, less than 100 bed or more than 100 bed. If it is less than 100 bed, then 340 liter per bed water is required, and it is more than 100 bed, 450 liter per bed water is assigned. Now, the last water demand is the fire demand. Last water demand is the fire demand. Fire demand, I have already told you that it will be the amount of water demanded to extinguish an fire accident. If fire accident occurs in a particular catchment area, then huge amount of water will be demanded. Where minimum amount of water required pressure is 1 to 1.5 kg per centimeter square. For fire demand, we need to know that there are certain things what we require to find out for fire demand. To find out the amount of water required to extinguish the fire is certain empirical formulas are being used. First formula which is used is Quichlink formula. That is the most old fire demand finalizing formula. In Quichlink formula, Q is equals to 3182 under root P, where Q is the demand in liters per minute and P is the population in thousand. Q is the demand in liter per minute and P is the population in thousand. That is the Quichlink formula. So Q is equals to 3182 under root P, but mind it, the unit. As these are the empirical formulas, you need to very much concerned about the units. Q is the population or demand in liters per minute. P is the population in thousand. That is also in this population in thousand. So as example, it is written here that if the actual population is 1 lakh, suppose the population in thousand for this formula will be, you need to just divide the value actual population by thousand. You will get the value as 100, which is the population in thousand value. So that is the first formula, most basic formula to find out the fire demand. Now, second formula, Freeman's formula, another formula where Q is equals to 1136 into P by 5 plus 10. 1136 into P by 5 plus 10, where Q will be in liters per minute and P is the population in thousand. Q will be in liters per minute and P is the population in thousand, the same meaning what we are going for. Parston's formula is nothing but the extension of Quisling formula, where Q is equals to 5663 under root P. 5663 under root P, Parston's formula. And the fourth one is the most important formula. It is National Board of Fire Underwriters formula. Actually, it is an organization of USA. They generally provide fire accident insurance. National Board of Fire Underwriters formula, where Q is equals to 4637 under root P into 1 minus 0.01 under root P. The first formula is Quisling formula, Q equals to 3182 under root P. Second formula is Freeman's formula. Third formula is Boston's formula. Fourth one is National Board of Fire Underwriters formula. And all, in every cases, Q is expressed in liter per minute and P is expressed in population in thousand. Now, I've written one question here to show you, or to if you can able to solve it, then you eventually will get the confidence to solve this question. Don't see the solution right now. I'll give you a certain time to solve the question also. It is not the whole solution itself. A community with a population of 1 lakh experience one accident per month. To put up the fire, it requires 5 hours period. Find the fire demand of the town in LPCD. Use NBFD formula. So let's go for the solution of the question. So here actual population is given as 1 lakh. It's told a community with a population of 1 lakh experience one accident per month. To put off the fire, it requires 5 hours period. Find fire demand of the town in electricity. So for this formula, P will be how much? P actual by 1000 is equals to 1 lakh by 1000 is equals to 100. But NBFD formula will be used where Q is equals to 467 under root P into 1 minus 0.01 under root P. Now, if you put the values in the equation, Q is equals to 4637 under root 100 into 1 minus 0.01 under root 100, which is, if you calculate it, it will be 41733 liters per minute. Now, total volume of water required to extinguish the accident, how much? So, as you are getting the Q value, आपको Q value किस में आ रहा है? As per the equation, as per the question, as per the formulation part, it's liters per minute. Now, total volume of water required to extinguish the accident will be 41733 into 5 into 60 liter. So it is 41733 into 5 into 60 liter. How? Because to extinguish the fire, you require 5 hours period. So you require 5 hours period. So as it is in liter per minute, as this unit is in liter per minute, so that's why we are converting this hour into minute and multiplying this. That is the total amount of water required. Now, what they're asking in the question, they're asking find the fire demand of the town in LPC liters per capita per day. एक चीज आपको याद रखना है कि एनवायरमेंटल इंजीनियरिंग में बहुत सारे प्रॉब्लम सॉल्व होंगे ऑन द बेसिस ऑफ यूनिट कन्वर्शन इटसेल्फ. Lot many problems will get solved on the basis of unit conversion. अगर आपका यूनिट कन्वर्शन वाला थिंग सही है, then you don't have to bother about other things. Lot many problems, lot many questions will get solved there. So here, so fire demand in LPCD. So previously what we have find out? You have find out the total volume of water in liter. Unit है liter per capita per day. So what will be the fire demand? Total volume of water required in liter per capita per day था, तो per नीचे क्या आएगा? Actual population. Then what will happen? Liter per capita into the per day वाला जो चीज है इसमें है frequency of accident. Frequency of accident. Now, frequency of accident will actually defining the thing. What is frequency? Generally, अगर यहाँ पे देखिए एक टर्म यूज है experience one accident per month. This is the term they have used. One accident per month. So when you are talking about the one accident per month, that means we are actually concerned about 12 accident in a year. One accident per month means 12 accident in a year. So if in a year there is 365 days, so eventually to convert it into days, it will be 365 by 12. So this is actually finding the frequency. So this is actually defining the frequency part. That is one accident per month. That is actually defining the frequency. The total volume of water required in liter will be equal by actual population into frequency of accident. So 41733 into 5 into 60, that is the total volume of water required that we have already estimated. That is the actual population of 1 lakh, and that is the frequency of accidents. So eventually, the final answer will be 4.117, or just rounded off with this second decimal, it will be 4.12 LPCD. It will be 4.12 LPCD. Now, we are written that factors affecting total demand. The factors affecting the total demand. First of all, I have listed the different factors जो आपको total demand को आपका affect करेगा, and then we will see that we will go for the description of those factors. Firstly, there will be size of the city. Then there is climatic condition. Then there is quality of water supply. Let me tell you the points, then I will explain it everything. Fourth one is pressure in the distribution system. Fifth one is types of habitat of people. Sixth one is cost of water. Seventh one is industrial and commercial activities. Eighth one is sewage facility. And ninth one is system of supply and policy. So, first factors it is listed here is size of the city. It is quite obvious that if the size of the city increased, eventually your total demand will get increased. That is very much evident. Then it is going for this climatic condition. What will be there for climatic condition? For climatic condition, whatever water is required for hotter and damper climate, obviously it will be much higher than the water required for colder cities or for cold weather. Even if you see for Delhi, if you go for the example of Delhi in the summer season and in the winter season, the temperature difference is enormous. So eventually there also water uses will be different when it's in the month of April and May, whether it is in the month of December, January. Now, second one is climatic condition. I have discussed. Then quality of water supply. Third one. Now, when we are talking about the quality of water supply, it is quite obvious that if the quality of supplied water is good to be used, then obviously it will use more amount of it will the water more amount of water will get used. Pressure in the distribution system. अगर प्रेशर इन द डिस्ट्रीब्यूशन सिस्टम में क्या आता है कि इफ द प्रेशर इन द डिस्ट्रीब्यूशन सिस्टम इज गुड, यू डोंट हैव टू बॉदर अबाउट दैट how much water is filled or how much time is required to fill the water in a bucket, then obviously water uses and water losses both will be higher. अगर देखिए सोच लीजिए कि आप बाथरूम गए हैं और वहां पे देख रहे हैं कि नल चला के और पानी भरने में बहुत टाइम लग रहा है बकेट में, तो आप कोशिश क्या करोगे कि आप मतलब वो जो पेशेंस लिमिट है वो उतना ज्यादा नहीं रहता है, टाइम भी नहीं रहता है उतना आदमी के पास, तो क्या है कि जल्दी जल्दी काम खत्म करके निकल जाना है, क्योंकि वो एक बकेट भरने में इतना टाइम लगाता है, तो अल्टीमेटली इफ यू आर वेटिंग फॉर अनदर बकेट इट विल यू आर गोइंग टू लूज सर्टेन अमाउंट ऑफ टाइम. But if you are not bothered, if the pressure is good, then obviously that particular thinking habit will not be there in your mind, so water usage will be abrupt. Fifth one is type of habitat of people. ये जो part है that is इंसान का आदत. I am not talking about good habit or bad habit, I am just talking about adat. Like let's give an example. Suppose an American person and an Indian person both have entered, suppose both are there in a same city and both have entered in a KFC store and both have ordered a chicken bucket. You know KFC chicken bucket, famous food. Now while serving the order, the KFC people will generally serve you with along with the tissue paper and all those things. So what the American people will do, American people will have that chicken bucket and they will clean their hand with the tissue paper and they will leave the place. What the Indian people will generally do, They will have that chicken bucket. They will clean their hand with the tissue paper and they will search for washroom because they need that they will wash their hand with water. एक्चुअली क्या है माइंडसेट है हमारे माइंडसेट में कि जब तक हम लोग पानी में टच नहीं कर रहे हैं तब तक क्या है कि वो हमारा जो हाथ है वो साफ सुथरा है नहीं सो इवेंचुअली दैट थिंग इज देयर आई एम रिपीटिंग आई एम नॉट टॉकिंग अबाउट गुड हैबिट और बैड हैबिट व्हाट आई एम टॉकिंग अबाउट इज द हैबिट then we are going for the cost of water then you're going for the cost of water then cost of water will be if the cost of water is higher so eventually the water uses will be lesser obvious relationship then industrial and commercial activities if the industrial and commercial activities of a city is more quite obviously then your water uses will be higher sewage facility ninth one is sewage facility if you're talking about the sewage facility then sewage is the part that where or we can say that if the sewage facility or the drainage system facility is good water uses will be more ninth one is system of supply and policy here it's completely law and order part and the municipality part where system of supply will be of in the right side you may have seen that system of supply will be of two type continuous system and intermittent system this continuous system this continuous system is actually also called as time independent system and this intermittent system is called as time dependent system so continuous system is time independent system and this intermittent system is time dependent system what is time independent system means throughout the day 24 cross 7 this system will supply water continuous system throughout the day 24 cross 7 water will get supplied in continuous system and what about for intermittent system intermittent system water will get supplied intermittently that means water will get supplied uh, in a particular time frame just to give I'm giving an example in some places in Kolkata most of the places in Kolkata or any small municipality areas Kolkata is a corporation area the water will get supplied like morning 6 to 10 then there will be a breakage in supply stoppage in supply once again 11 to 1 water will get supplied and after that 4 to 7 water will get supplied or 4 to 6 like water will get supplied so in continuous system it there will be no stoppage or there will be nothing will in your mind that we need to finish our job quickly so water uses and water losses will be both will be more in continuous system whereas in intermittent system there will be always a thinking process will happen in the backdrop of our mind that okay if I won't use this water right now or for my this for this purpose then water will not be supplied after this point of time so eventually water uses will be more optimal and losses will be much more less that is intermittent system and continuous system over there now the variations in water demand variations in water demand when you're talking about the variations in water demand then certain things we need to remember first of all the average daily water demand that is defined as q average or generated by which is nothing but the population into per capita demand, which I have already discussed with population into per capita demand, which I have already discussed with you. After Q average, there will be maximum daily water demand, which is defined by Q max daily. The maximum daily water demand, which is defined by Q max daily and equated by 1.8 into Q average. 1.8 into Q average. Third parameter is maximum hourly water demand. Maximum hourly water demand, or also called as peak demand. Maximum hourly water demand, also called as peak demand, which is called as Q max hourly, where that is equals to 1.5 into Q max daily. Q max hourly is equals to 1.5 into Q max daily, as Q max daily is 1.8 into Q average. We have mentioned here 1.5 into 1.8 into Q average is equals to 2.7 into Q average. 2.7 into Q average. So these are the three parameters here. Average daily water demand, which is Q average, or Q, which is population into per capita water demand. Then maximum daily water demand is 1.8 into Q average, which is Q max daily. And Q maximum hourly water demand, which is also called as peak demand, which is equals to 1.5 into Q max daily, which is 1.5 into 1.8 into Q average, which is 2.7 into Q average. Now, now here, after the going for these variations in water demand, we need to know about two terms. That is, first one is coincidence draft. Here, draft means depth of water, which is equivalent to the demand. Means draft and demand both are same term. Another one is total draft or total demand. What is coincidence draft? Coincidence draft is the addition or summation of maximum daily water demand and fire demand. Coincidence draft is the addition or summation of maximum daily water demand and fire demand. That is coincidence draft. So coincidence draft is the addition or summation of maximum daily water demand and fire demand. So, or we can say it as Qmax daily plus fire demand. Where when we are talking about total draft or total demand, here first we need to compare between two terms. First of all, coincidence draft, and secondly, Qmax hourly. First, we need to consider two terms. One is coincidence draft and second one is Qmax hourly. Whichever is higher, whichever is higher, your total demand will be that value. Whichever is higher, your total demand will be that particular value. So for coincidence draft, it will be the addition of maximum daily demand and fire demand, and total draft or demand is maximum among coincident draft and maximum Qmax hourly. coincidence draft, and Qmax hourly. So first you need to compare between the values of coincidence draft and Qmax hourly. Whatever is the early, whatever is the higher will be your will be your total demand. Okay. So and your Qmax hourly will be 2.7 into Q average, or it's 1.5 into Qmax daily. And um, this Qmax daily is nothing but 1.8 into Q average, and if whether your Q average is nothing but population into per capita water demand. The Q average is nothing but population into per capita water demand. Now, one thing we need to discuss about is the design period. One thing we need to discuss about is the design period. Design period means the utility period or useful life period. It is utility period or useful life period for which a particular design, environmental design or civil engineering design, whatever it may be, it is assumed that it will work for those particular time frame in its highest efficiency. Now, to find out the design period, there will be a plot between probability of failure versus time. There will be a plot between probability of failure versus time. Now, when we are plotting probability of failure versus time, then that graph is there. This particular graph is there. So you will see it first at the starting of the moment. It will keep on decreasing. It will keep on decreasing. Obviously, probability failure of will be keep on decreasing, and then for a higher amount of time, it will be same. It will be same. It will be same. It will be same. So that means it will be parallel to x-axis, and then but after the time it will keep on increasing in a straight line. Quickly it will increase. So the time frame for which this probability of failure is actually constant with time. That particular time frame is called as design period. So the time frame for which the probability of failure with time, so the is constant with time, is called as the design period. That particular time where it is constant with time is called as the design period. By definition, here it is mentioned, it is the future period for which provision is made in designing the capacities of various components of water supply scheme. It is a future period for which the provision is made in designing the capacities of various components of water supply scheme. Okay. Now, we need to go for a table. That particular table is defining the different components of water supply scheme, their design demand, because not all the water supply scheme is designed in a particular demand, and the design period, for what amount of period they are getting designed for. Firstly, there is dams or storage reservoir. Dams or storage reservoir, it is designed for Qmax daily. Dams or storage reservoir, it is designed for Qmax daily, and design period is estimated as 50 years. Then intakes, it is also designed for Qmax daily, design period 30 years. Conveying pipes, also designed for Qmax daily, and design period is 30 years. Pumps design demand is 2 into Q average. Take a point. Design demand for pumps is 2 into Q average and design period will be 15 years. Treatment unit except rapid sun filter. Rapid sun filter RSF, apart from that, for all the treatment unit will be designed for Qmax daily and the design period is 30 years. Designed for Qmax daily and the design period is 30 years. Rapid sun filter RSF is 2 into Q average design demand and the design period is 15 years. Rapid sun filter it is designed for Q2 into Q average and the design period is 15 years. For distribution system, total demand, design demand is total demand and design period is 30 years. So what is total demand? It's maximum among coincidence demand and Qmax hourly. What is coincidence demand? It's the summation of Qmax daily and fire demand. Okay. So quickly have a look what we have done today till now. These are the course overview: water supply engineering, wastewater engineering, solid waste management, air pollution engineering, noise pollution engineering. First two segment is the watery part and second three segments is the non-watery part. Once again I am telling you, noise pollution engineering is not in your gate examination syllabus from this year. I am here, I will cover, it's a small part I will cover because of your PSU examinations. Once again I am telling you, don't get confused. Water supply engineering, generally from this whole environmental engineering segment, 10 to 12 marks is expected. 10 to 12 marks is expected from this whole environmental engineering segment. From this 10 to 12 marks, if we see the classification, generally water supply engineering 5 to 6 marks, wastewater engineering 4 to 5 marks, solid waste management to air pollution engineering to noise pollution engineering. For or noise, if you remove that noise, that particular segment will give you 2 marks around. And nowadays what is happening, this particular segment, solid waste, air and noise, this particular segment importance is keep on increasing. That particular segment importance is keeping on increasing and this is also in high magnitude. Then we are going for this objects of environmental engineering. We have explained it that two objects are there. One is protect the human being from environmental factors. Another one is protect the environmental or environment from human induced factors. Okay. Then we have discussed this water supply scheme and that water supply scheme. If we are talking about this segment of then first you need to collect the water and then we will go for this conveyance of water, then you need to go for treatment, then you need to distribute the water to the community and that particular community will produce the wastewater and that wastewater will get distributed among the community. Wastewater will get disposed of, but before disposing of the wastewater you need to treat it properly. Okay, that we will see in wastewater engineering. where you are actually protecting the environment from human induced factor. And above it is आपके लिए क्या है कि that is water supply engineering, where you are actually dealing with the protect of human being to environmental factors by environmental induced factors. So here to design water supply scheme and water disposal scheme, we require the discharge Q. Q will be population into per capita water demand, and I've explained it in details that if you are increasing the population, then Q value will increase, and per capita water demand is constant for a particular catchment area, for a particular purpose, and for a fixed time frame. Per capita water demand, it is defined as the average amount of water demanded by an individual living in the community to meet all his or her day-to-day water needs. Okay, from the definition itself, it is very much evident to understand. Now, per capita water demand, by definition, it is defined as annual average water consumption of a community by population into 365. Generally, it is expressed in LPCD, liters per capita per day unit. Then I've told you the what are the chapters, then types of water demand listed here: domestic, industrial, institutional, demand for public uses, compensating losses demand, and fire demand. There is a segment where for different domestic purposes, how much water is assigned for LIG and HIG group, it is mentioned over here. Now, a brief discussion about industrial water demand, demand for public users, and compensating losses demand. Very brief discussion about. Then is discussion about institutional or commercial water demand, and where certain institution or commercial places are being listed here, and those uh, data or the value which is assigned for them is also listed over here. You have to remember it. Again, I am repeating that it is not like you should not expect a question like this for gate exam, but yes, for IS prelims and for PSU exams, this segment is very important. You can expect one or more than one question from this particular segment. Now there is next one is fire demand, and where the fire demand, it is to find out that what will be the amount of water required to extinguish a fire accident. Empirical formulas are being used. Quicklin formula, that is Q equals to 318 to under root P. Then it's going for Freeman's formula, then Boston's formula, then National Board of Fire Underwriters formula. So there are certain formulas are provided, and units. Units are very important to know because this is completely an empirical formula. So eventually, units requirement is very required. Uh, and we have solved the question. We have seen that how we need to find out the fire demand in LPCD, bits and bits of this segment we have done, and eventually we know the thing about the frequency of accident, which is very important to know. Frequency of accident. And here I have explained, as per the data, I have explained everything that what else is there for this frequency, this finding out this fire demand in LPCD. Then we have gone for the factors affecting the total demand, where size of the city, climatic condition, quality of water, present in the distribution system, everything is listed, and we have explained it. And then finally, we have gone for the system of supply. What is continuous system? What is intermittent system? What is time dependent system? What is time independent system? Where in which case water losses or water usage will be more. Everything is discussed. Then we have gone for these variations in water demand, where average daily water demand, Q average is equals to Q in population per capita demand. Then maximum daily water demand is 1.8 into Q average listed. Maximum hourly water demand is 1.5 into Q max a daily also listed, which is equals to 2.7 into Q average. Then we have gone for two things, that is coincidence demand and total demand. Coincidence demand is nothing but the summation of maximum daily water demand and fire demand, and total demand is maximum between coincidence demand and Qmax hourly. So first you need to find out the Qmax daily and fire demand, and then Qmax hourly. Then you need to add Qmax daily and fire demand, and you need to check that those addition value, which is coincidence demand, is more than Qmax maximum hourly demand or not. Whichever is higher, if Qmax hourly is higher value, then it will be the value will go for total demand, and if coincident demand is having higher value, then it will be total demand. Then we have explained the concept of design period with the graphical representation, and the definition is also provided. Okay. And then finally we have gone for this, the components of different components and their design demand and their design period. Different components is listed: dams, storage reservoir, intakes, conveying pipes, pumps, etc. Their design demand, sometimes it is Qmax daily, sometimes it's 2 into Q average, total demand, whatever it may be, and design period is also mentioned here. So that's the end of water demand segment. So, and after the water demand segment, so what we need to go for? We need to go for this population forecasting that we will discuss in the tomorrow's session. The different methods of population forecasting, different what is population forecasting, some problem solving approach will be also there. That is there in the population forecasting chapter. So apart from this, once again I am repeating the that you can go for GATE 2022, whoever is, or your juniors, your brothers, sisters. The batch is starting, is going to start from 28th December, 11:15 a.m. And there is recently there will be a thing, Unacademy Combat, which is the largest fortnightly competition for GATE. Challenging GATE questions created by best educators of Unacademy, and super fast and fun with real-time rankings, compare with the best detailed video solution by top educators. All these things you will get, and for registration or enrollment you don't have to pay anything, it's free. Time and date is mentioned here, and first prize will be the MacBook Air, second prize is iPad Mini, third prize is AirPods, and top 100 rankers will get each 1,000 Amazon vouchers. This is my code ACN10. For this, you can go for this pricing part. If you're not installed, you just install an Academy Learning app, go with the installation, and then click that Gate and EAC segment. Then you can go for an Academy Plus. This is myself, Soumyajit Sen, and I'm going to deal with your environmental engineering segment. So that is for today's class. We will meet tomorrow. Tomorrow we will go for the second segment of this chapter, first chapter, that is population forecasting. We have completed the first segment of the chapter, that is water demand. We will see tomorrow the second segment of that chapter, population forecasting.